Welcome back to the MVA, and we're going to be drawing some architecture here on DevOps. I
Yes,
just wanted to introduce ourselves. I'm Windowser, and this is the Book of Doodle.
that's me. I am the Book of Doodle.
So, Derek, DevOps. We
Yeah.
talked a little bit about it.
Yep.
Maybe we can draw out some scenarios here around some of the interesting
I'm going to
things
use
that we
the
do.
pen.
All right.
All right. So DevOps is really, really cool. In the a previous module, we talked about how you may have your DApp developers working one stream, the front end interface. It could be the UX designers. We also talked about how the folks writing the smart contracts will be could be a different team. But what does that ultimately look like insofar as a DevOps process? So here I go to the whiteboard. Over here on the left-hand side, get out of the way, Kale. Over here on the left-hand side, I've got two different streams here, and I'm going to use UX/DApp, and that could be ASP.NET, MVC, JavaScript, Swift, whatever it is that you want. Then here, you might have the smart contract folks. Now, they're going to be working in their own threads, maybe even in their own language. And as we go along here, these guys will check their code into GitHub or any other repository that you want. GitHub could be happening here as well. And along the way, the developer of the UX and the DApp, they're going to be using traditional tools that you would be familiar with right now, whether it be Photoshop or Visual Studio, whatever. The smart contract developers, again, we talked about all the different frameworks and tools that you might have available to us. These guys are going to be set up a little bit differently. Kale, give me a couple of examples here of some things that we might have on the local person's PC.
Yeah, I mean, we talked about a couple of them earlier there. One could be even the online Solidity compiler. They could
Okay.
just be writing directly in their browser. They could be using something like the EtherCamp product of Ethereum Studio, which is kind of a self-contained IDE and kind of deployment. It actually encompasses some of the DevOps in a box.
So this one, the Solidity compiler, is open source.
That's correct.
Okay. And what was his name again?
You can call that Cosmos.
Cosmos,
That's the one that's
yep.
up there, the online Solidity compiler.
Cosmos.
And then
EtherCamp by
EtherCamp is
EtherCamp.
Ethereum Studio is their product
Okay.
that they have out there.
And that's a closed source. That's a product that it's a kit that you can buy and develop on.
Yeah, it's a single VM image inside Azure. You can just go up and spin up an instance.
Oh, from
of
the
it.
marketplace.
Yeah, and you got an endpoint. You can just bounce against it, and you're off to the races. Again, through your browser.
Right.
So once it stands up, you just go to that private endpoint. You're good to go.
But if I were a developer on a traditional, I've got my Surface Book. It's got Visual Studio in it. I want to do some on-device modeling of my smart contract. I might have something like TestRPC. I might have Truffle installed. I might have VS Code or Visual Studio. I like VS Code because there's a very cool integration pack that works with the Solidity language. So you can get some great text highlighting. You can get, Truffle's going to take care of setting up my framework and kind of scaffolding it out. What other things are going on here?
Yeah, I think the difference, if you draw a contrast between what VS Code is and what something like Visual Studio brings to the table, so full Visual Studio, there's a lot more visual elements, but obviously they can do things like the deployment much easier, where VS Code's more modular based. You're going to pull a package in to do the deployment, whether it's Dapple or Truffle or something like this, you can actually pull those in and start using them to do it. Yeah, so these are different frameworks that allow you to kind of orchestrate the functionality of doing that. So you're basically doing this as a code editor, and it's helping you write code and make sure that it's compiled and everything. And this is handling more of the DevOps of deployment side.
Right. And when I was getting started on this, I had TestRPC up and going. It was helpful. I opened this up in Chrome, but there were some other things that I needed going on down here. I was able to do a lot of it in PowerShell, but dropping down into the command line, you're going to need to do some of those things. What other types of kit would you need on a smart contract developer's box? Is this really about it?
Another big one, so this is really focused around core Ethereum, like we mentioned earlier. We also have Strato, remember, with
That's
block
right.
apps. So one of the cool things that those guys have done is actually stood up a dev box that's running in the public space. So it's called Strato Dev 4 right now. So if you just go Strato-Dev 4, if you go out there to that endpoint, .blockapps.net, there's actually a Strato instance running there that you can just use freely.
Okay.
So if you just wanted to start bouncing code around and see how you can upload contracts, you can play with it, see how it works. Obviously, it's in the public space. So if you're concerned about your IP and things like that, you want to keep it safe, then you would spin up your own instance of Strato.
Okay. So once I have my code, that's going to take place, and again, I'm focusing on the smart contract guy. I'm going to have some .sol files.
Yeah.
I'm going to have, what other kind of files am I going to have?
Well, this is primarily going to be your smart contract output, right? You're going to have some .sol files. You're probably going to have some accounts.
This is bytecode.
Yeah.
Okay, so this is the bytecode that would get ultimately copied and pasted into like Mist or wherever. And
Correct.
We'll get into that here in a second.
I mean, obviously, we've created some accounts and things that we're using here, but we shouldn't have any hard references to that. It's something to keep an eye out for. Don't be hard coding those things in here, because as we move through our different, maybe like a staging environment or a dev environment into a production environment, we don't want to have those dependencies. It's going to cause breakage later.
Okay. So any other type of files that the smart contract guy, ultimately he's going to end up with a .sol.
Correct.
What else has he got?
This is really his primary output, and the DApp guy is going to have a lot more stuff, right? He's going to have, what chain am I talking to? Am I talking to test RPC? Am I talking to Strato? Am I talking to public Ethereum? Whatever. So he's going to have all the configuration for that kind of thing. And again, that stuff should be in configuration files. So as you're putting that through, this way you can move between environments easily.
Okay, and so from a DevOps perspective, and this would be very familiar to organizations that are just deploying to Azure, like Azure Web Apps. You might have config files that specify dev, test, stage, prod, and these are reporting out to the different blockchain networks that you might be working with.
One of the cool things you can do too, and we're talking about DevOps, is this is kind of like your primary output that Derek's talking about here, but we also have to orchestrate maybe testing. The Truffle has a really good test framework inside of it that allows you to write unit tests essentially for your chain. So you can use those, and one of the neat things is some of the guys in our teams are starting to write Visual Studio Team Services extensions. Right? So you can write these yourselves. You can go up to the site and build these. They're relatively easy to build. You can use some of the out-of-the-box stuff that we have up there. You can build a custom agent if you would like. But essentially what you're doing is building up a framework over here so it can execute your Truffle tests as part of your build and deployment.
So I'm going to change up my scenario here. I'm going to put this in VSTS as opposed to GitHub. And the reason I'm going to do that is I'm going to kind of extend on what we've been talking about here. So our developers are using VSTS or GitHub, but because we've got this framework out here that we can work with, we'll just kind of go from there. So you've got your developers, and the process is going to look very familiar to what you would be expecting in any other application. You've got your developers. They are going to check into source control. Inside your source control, you may have unit tests. You may have all of the other things that you would have as part of your DApp. So you would have user stories. You may have user experience, the original imagery files, all of the things that create your application holistically.
Off-chain storage as well.
Yep. So down here, you may also have release management. That helps coordinate all of this stuff to go from dev to test, which runs your unit tests, which cycles your off-chain storage, which resets your blockchain. And then if all of those tests pass, then you move on to a different environment. For the sake of argument, let's say that our test environment all happened in memory. So you could write that from a build agent. You could write that just in a VM that gets deployed. You run your stuff, you test it, and then you just throw it away. Then your integration testing might be a non-prod blockchain that you would have. So from there, let's kind of start a new board here. You've got, just thinking from an infrastructural perspective, here's Azure. You've got your developers on one end. One thing we didn't talk about was dev test labs. So you can set up individualized images for each developer to have their own development experience so that it doesn't all have to be on their own VM. One of the key things that this empowers is because the tooling is changing so fast and so rapidly, keeping everyone up to snuff on the same versions, and they're iterating constantly off of GitHub, keeping those frameworks up to date becomes very important. So they may be using dev test labs. Then the infrastructure guys for test may be just one or two VMs that are small enough where everything runs in memory. Then you've got int or UAT. These may be actual non-prod blockchains. So if you were to spin up a consortium network within Azure, you might be talking about, say, like a 5-node blockchain environment. And that helps to then make sure that all of your asynchronicity is doing well.
Mm-hmm.
And then, finally, you get through your release management pipeline, then you get to prod, which could be a much bigger environment. And the release manager environment, it may be helping to control what goes out to the public blockchain or to the public consortium member. But it also is a great place where the security layer can come into play. You would have, for instance, different key vault policies here than you would have here, maybe no key vault here because it was just in memory. And so, as you can see, it looks very similar to what a DevOps workflow would look like from a traditional application development standpoint, but there are some things that you want to take into consideration as you're developing these two different major threads, again, the UX versus the smart contract. And that's no different than you would have different tiers of things happening in a traditional application development experience. This could be the mobile guy and this could be the web guy. But it's important to note that Azure is going to provide you with a lot of great tooling. DevTest Labs, if you've not seen that, definitely check that out because it allows you to templatize what the end user developer is going to be needing and keep all of the frameworks and tooling up to date.
Yeah, I think Azure is the perfect fit for this kind of thing because it's very easy to spin these things up very easy, the infrastructure behind the scenes. So we templatize them, make them very easy to spin up, and then it just becomes a switch to turn them on and off, whatever we need. And then production, obviously, is a much more vetted.
Yeah, it was a great use case story about that because I spun up one. It was like a 50-node cluster just to see what I could do with it. And it was in multiple different regions, and I spun it up, and it worked great. Then I started powering down different regions to see how I could inject forks and soft forks so that I could tell how is my code going to behave in the real world. Azure makes that incredibly, incredibly easy to do. So there you go.